Я вітаю нашого наступного доповідача, доктора технічних наук Станкевича Сергія Арсенійовича, професора, завідувача відділом наукового центру аерокосмічних досліджень Землі НАН Україну. Темою доповіді пана Сергія буде виявлення наземних мін на сільськогосподарських угіддях за допомогою оптичних та радарних малих безпілотників. Прошу, можете починати.
Доброго дня. Good afternoon, ladies and gentlemen. My name is Sergey Stankevich. I'm Head of Department and the Scientific Center for Aerospace Research of the U.S. National Academy of Science of Ukraine. So, our center is a multi-purpose, interdisciplinary scientific research institution, which provides the study in many areas, including the geology, geoecology, agriculture, forestry, and so on, using the remote sensing methods and technologies. So it is today my presentation is about the landmine detection in farmlands using optical radar small drones. It is very challenging and very actual for Ukraine problem. So the huge area of Ukraine is under impact of warfare, including the dense and very dangerous mining and other explosive objects contamination. So if you will use traditional demining technologies such as the personal deminers, the demining machines, and other technologies, the demining of Ukrainian territory will be extended up more than 100 years. So it is impossible in current situation, and new technologies must be implemented to enhance the demining performance and possibilities. First of this new and very prospective technology is using the small drones for mining detection, landmine detection, and mapping. Our experience start in 2020 when the National Academy of Ukraine, established a defense research program intended for support the military activity in Ukraine and the Ukrainian armed forces. So our experience start with the small China manufactured drones equipped with multispectral infrared cameras and pulse spectrometers intended for obtaining the precision spectral reflectance of targets under the drone. So this equipment was tested in real life over the special test sites intended for demining training, and the statistical performance of landmine detection was assessed. The most challenging problem in landmine detection using the small drones is image analysis, which is acquired by drones, and detection landmines and other objects of interest in multispectral, infrared, and other types of imagery. Now we propose some stage for landmine detection workflow, including the optical imaging by drones, image analysis, and image solution fusion based on classical statistical methods for target detection in multispectral images. As for the methods, it needs some processing parameters, the specification of camera and other imagers on board of drone, and in case of multispectral or hyperspectral camera is a reference database which includes the all target landmines spectral signatures or high resolution spectral obtained in laboratory conditions. During our study, we test a lot of mathematical and algorithmic methods for landmine detection in multispectral and infrared imagery. So it is a very complicated problem because the statistical distribution of target is very blurred and unstable in time. So we use the general likelihood ratio test, the support vector machine, and other classical machine learning algorithms to detect landmines in multispectral and infrared imagery. Most successful it was detected the logistic regression approach, which includes some possibilities to landmine detection in under uncertainty condition, which are inherent to multispectral imagery and more or less to the infrared temperature maps of landscapes. So the engine of spectral libraries or spectral signature libraries into the workflow for landmine detection is need to provide the radiometric calibration of onboard cameras intended for this purpose. So unfortunately, our manufacturers, which provides the multispectral camera, do not provide the software and algorithms for radiometric calibration. So we was need to develop software itself and provides the special purpose software for radiometric calibration of multispectral camera provided by DJI China manufacturer. In this slide, you can see the examples of landmine detection, both buried and open within grass and other types of land cover. under image acquisition from small drones, it is first and second images are the conventional color image and false color synthesized multispectral image, and bottom image is a probability of landmine distribution mapping. So you can see more or less efficient detection, both not only the open landmines, but also the buried one under the dry grass. This slide provides an example of landmine detection using the infrared imagery, which map it as a temperature field of landscape with landmines and without one. It is a very useful instrument for landmine detection, but it works properly only in special hours in day when the thermal contrast occurs between the landmine and the ground. So in 6 of morning or 9 past morning, it is possible to detect landmine, but in middle of day or afternoon, it is not possible because the thermal contrast is equalized between the mine and the ground. So both type of imagery can be processed and analyzed by proposed algorithms, and final stage of decision making is a probability fusion, when the probability by multispectral imagery and landmine probability by infrared imagery fused into joint probability. We use the special type of mathematical techniques based on uncertainty analysis and provide most efficient decision under uncertainty condition. The important task of wide-scale landmine detection is a mission planning of small drones. So maybe all manufacturer of small drones provides a mission planning system software with its drones. So it is very simple systems intended for path routing and connected with the navigation computer on board of small drones, but all of this version of software need the resolution of target imagery. So the resolution is a key problem in landmine detection. So because our research found that the resolution of small drone imaging may be 1 or 2 centimeters in length, need is a not very high altitude of drone flight. It is typical altitude is equal 10 or 20 meters over the land surface. So our version of mission planning system integrated in open source QGIS software intended for calculation of necessary resolution for landmine detection with some threshold of probability, and then we can to provide key parameter for standard mission planning system as a altitude of flight. So also this software taking into account the weather condition such as wind speed and other possibilities, including the battery charger, and also we can calculate necessary number of drones to provide total imaging of predefined area. Our experience is our experience in landmine detection is provided not very good inference. The not only possible types of drones is not enough to detect landmines in any situation, any position, and with acceptable probabilities. So our intent to include the signal-based sensors on board of small drones, such as the ground penetrating radar or magnetometer, into the workflow for landmine detection. It is very complex problem because the source of such signaling sensor in ground is very narrow, and so it is need a more essentially more path for territory scanning. That we propose a combined technology when the candidates of landmines detected by optical imagery, and then the ground penetration radar or magnetometer make a special purpose flight to provides additional information about landmine candidate. It is a real landmine or it is a mistake. So it is part of our research need as a great funding because the ground penetrating radar of high frequency intended for drone-based application is very expensive. It cost start from $80,000 and more. It is need to buy this equipment for practical training and performance assessment. Other possibilities which provided in latest scientific results in image analysis and target detection is integrated convolution neural networks in detection contour of workflow. So now we provide some research from open source convolution neural networks integrated in our workflow, and some results will be more or less prospective. So, short conclusion. As our experience and experiments provides the conclusion that the sub-centimeter resolution imagery from small drones is possible to use in landmine detection. It is will be a very useful tool for demining troops and for the risk decreasing of territory demining. So, as a universal method, applicable any universal method for landmine detection, but the possibilities of data fusion is possible to enhance the performance of landmine detection and provides more or less acceptable probability of landmine detection and false alarm probability. So, and future research should be focusing on integrated of signal-based drone sensor into the our flow, and it is also will be useful for probability enhancement of landmine detection in the farmlands. As for farmlands and agricultural application of proposed technology, it is most useful for small drones, because it is impossible to use small drones in forest, in urban territory, and the agricultural area is most useful for this purpose and for many application of landmine detection. So in very flat and without landscape without obstacles for drones fly. If you're interested in our scientific background and results obtained in our experiments or our theoretical developments, so please you can read the peer-reviewed publication in international and Ukrainian publishers, and it is most of this publication is open access. So thank you for your attention and opportunity to make my presentation in our conference. Thank you very much.
Дуже дякую, пане Сергію. Я продовжу на українській мові, тому що в мене налаштування вже стоїть, але ви можете відповідати англійською. Питання, чи цей підхід підходить до малих протипіхотних мін, так звані пелюстки?
Так, цей підход підходить так для пелюстків, тому що це різновид мін, який не має принципових відмін від інших типів, за виключенням розміру. Але наш підхід дозволяє гнучко регулювати розрізненість зображення для будь-інших типів мін, включаючи і пелюстки.
Чудово, дуже вам дякую. Дуже багатообіцяюча, вірніше вже діюча технологія.